This comes out of section 8.3, logarithmic functions. I want to talk about the letter E. As we saw in an earlier section, E is approximately equal to 2.718 decimal. The natural log, they call it the natural logarithm, is just when you do a log that's base E. So if I do log base E of x, or they usually will write that as ln x. Natural log is done so often that it has its own little abbreviation for it, and natural log of x. So if I said, what's ln of e? Really what I'm saying is log base e of e. So in other words, e to the power of what equals e, and the answer to that would be 1. If I said, what's ln of 1? Well, any log, let alone base e, but e to the what equals 1, the answer is 0. Now if I do something else like natural log of e to the x, the answer to that one is just going to be x. And again, you could use your log rules and say x ln e, which just is x times 1. If I were to do ln of e, sorry, we did ln of e. If I did e to the ln x, this one is a little bit of a weird one. And the answer to it is x, and let's take a look at why. And you've run into questions like this before, but basically I get asked them each time. 5 to the log base 5 of 25. If I did that, if I first asked you what's log base 5 of 25, hopefully you would say 2, because you're saying 5 to the something equals 25. The answer to that is 2. So then I'm saying, what's 5 to the 2? Well, you kind of already answered that question. You've kind of just been asked to do the operation forwards and then backwards. And so e to the log base e of anything is going to just give you that number that's up there, because the first question says e to the what equals x. You come up with an answer, and I say, what's e to the power of that answer? And you get x. Not a hugely important concept, but something that we can use in some derivative stuff in the next lesson. Now let's take a look at a specific example. What if I asked you solve for x, and we're given ln x equals 5. You have a natural log button on your calculator, assuming you have a scientific calculator. It doesn't even need to be a graphing calculator. And if you take a look at the second function of that, it usually is e to the power of something. The reason why is because if you do log base e of x equals 5, to figure out what x is, you're going to say e to the 5 equals x. Now in exact values, that's it. That's your answer, because e to the 5 is not going to give you a nice round number. There's not really any reason to punch that into your calculator. Now, if we do another solve question, and we solve this one, it says e to the 5 minus 3x equals 9. The best way to go about this is to log both sides. When we've done exponential equations in Math 30, the variables and the exponent, you have to log both sides to get it down. In this case, it's going to be even better if you natural log both sides, and I'll show you why in a second here. If we natural log both sides, we can use the log rules to once again take down that exponent and say, okay, it's 5 minus 3x times ln of e equal to ln of 9. The beauty of ln of e is it just equals 1. We saw that way up above at the top. So what we have here is 5 minus 3x equals ln of 9. Now some people will get excessively confused by that ln of 9 business. It's just a number. So really you could say, do a little rearranging, 5 minus ln of 9 equals 3x. So x equals 5 minus ln of 9 divided by 3. Again, in exact values, you're done. If somebody asks you to find that to the nearest tenth, you just crunch those numbers on your calculator and figure out what 5 minus ln of 9 divided by 3 is.